This is practice A for section 7.6. We're looking at the back. We're going to use the 45-45-90 triangle theorem or the 30-60-90 triangle theorem to find sine and cosine of the angle. We did this in our lesson, so there is a video on this if you're not sure. If you want to stop this video, maybe watch that one first. It'll explain how you do it. In a 30-60-90 triangle, I'll just draw this for reference. Our short leg we're going to call x, our hypotenuse would be 2x, and our long leg would be x times the square root of 3. So if you want the sine of a 30-degree angle, sine is opposite over hypotenuse. That's x over 2x. Which equals, when you cross the x's out, 1/2. Cosine of 30 would be the adjacent over the hypotenuse. So it's x squared root of 3 over 2x. Again, cross the x's out. You're left with the square root of 3 over 2. Those are your sine and cosine ratios. I don't need a calculator. I know what the ratios have to be. Regardless of what x is, the ratios will be the same because the x's will always cancel. 45-degree angle. When you have a 45-45-90 triangle, your legs are the same and your hypotenuse is a leg times the square root of 2. So if you want sine of 45, let's say we're using this angle, sine of 45 is going to be y over y plus 2. I think I said y plus 2. That's y times the square root of 2. Whoops. Cross out the y's. You end up with 1 over square root of 2. That's the sine of 45. Now, the cosine of 45 would use the adjacent over the hypotenuse, which, if you notice, it's the same exact thing. Cosine of 45 is the same ratio, and that's because it's a 45-degree angle, so it's a right isosceles triangle, so these legs are the same. That's why that works that way. Okay, sine and cosine of a 60-degree angle. So here's your 60. Sine would be opposite over hypotenuse. So it's going to be the same as your cosine of 30. Cosine of 60 would be the adjacent over the hypotenuse. So it'll be the same thing as the sine of 30. That's how you do those ones. You actually don't even need the triangles if you're thinking correctly. Next section says to find the unknown side length. Then find the sine of A and the cosine of A. Write each answer as a fraction in simplest form and as a decimal, around to 4 decimal places. So the first thing you got to do is, given two side lengths, you got to find the other length. Okay, so remember Pythagorean theorem. This squared plus this squared equals this squared. So if I want that hypotenuse, I'm going to take the square root of 28 squared plus 45 squared. And I get 53. Now if I'm going to write ratios, sine of A and cosine of A, I can do that because these lengths are whole numbers, which makes it really easy. Sine is opposite over hypotenuse. So it's 28 over 53. Cosine is adjacent over hypotenuse. So it's 45 over 53. That's really all I'm concerned with. I know it says something about decimals. I'm just concerned with the fraction. And notice how they're asking you to find the sine of A and the cosine of A. They're not asking you to find what A actually is. If you wanted to find what A would be, you would take the inverse sine of that fraction. It'll give you a degree. It'll tell you the actual measure of that angle. Okay, but you didn't need to do that. That's if you have your legs. That's how you find your hypotenuse. Well, what if you don't have your legs? Now, these end up being triples. I know that because I know my triples. 7, 24, 25 times 2 gives me 14, 48, 50. I know that's 48 without even calculating anything. Let me show you how I know, though. If you don't understand the triples or don't remember them, we're subtracting this time because we have the hypotenuse. That's why we're subtracting, opposed to last time when we added. 50 squared minus 14 squared, this is going to give you 48. Now, you want sine of A, you want cosine of A. We're just concerned with those fractions. Here's angle A. Sine is opposite over hypotenuse. 14 over 50. Cosine of A is adjacent over hypotenuse. 48 over 50. You can reduce these if you want. You can type them in your calculator and get the decimal like they ask for, but this is fine. Because really what's going to happen is eventually you're going to find this angle A just by taking the inverse sine of that fraction.